In this example, we're asked to construct a frequency distribution with some given parameters up here, that the first class has a lower limit of 30,000 and the class width is 6,000. And I'm going to show this first by hand because this list is relatively small. So I'm going to start building these class intervals. And again, we were told to start with 30,000. The beginning of the next interval will be 6,000 more than that. That's the class width. So in other words, I'm adding 30,000 plus 6,000 to get 36,000. To get the beginning or minimum value of this next interval, I'll add another 6,000. So 36,000 plus 6,000 gives us 42,000. And I continue doing that process until I reach that last class interval. Now I want to say how far these classes go. What is the interval's maximum value? It should be one less than the minimum value of the next interval. So let's back this up 1 unit and we'll get 35,999. And I'll do the same thing for the next class interval. So if I want to know how far it should go, I don't want it to overlap with this next interval. So let's go 1 unit back. We'll subtract 1 and get 41,999. And I continue doing that process. And also notice that these are 6,000 units apart. I could also just say 41,999 plus 6,000. And then 47,999 plus 6,000. And now that I've found the lower and upper class limit for each class, I'm going to come back here to the data and count how many pieces of data are within each class. So this first class interval is from 30,000 to 35,999. And if I look through my chart, I'm counting how many values are between those two numbers. So I get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. The next one is beyond that. So I only have 14 values here that are within that class. So if there's 14 pieces, 14 counts, or frequency, that's how often it occurs, that I have data between 30,000 and 35,999. Now I'm going to do that for the next interval. How many pieces of data are in this interval? So let's see here. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 pieces of data, 10 counts is what we counted, 10 things here in this interval. For the next interval, okay, I come back here to my data, but I don't see any data between 42,000 and 47,999. So there are 0 pieces of data there. And then for this last interval, there's just this 1 piece of data that falls within that interval, so there is a 1. Next, we're asked to construct a relative frequency distribution of this same data. The good thing is I can just repeat these same classes above down here. Next, I want to find that relative frequency. And instead of coming back to the entire chart of data, all that raw data, I can just use this frequency chart now that I know that it's correct. So to get that relative frequency, I first need to find how many total pieces of data were there. I could either add up all the frequencies, or I could come back up here inside my problem. I was told that there were 25 pieces of data. Now I'm going to take each frequency and divide it by the total. So 14 divided by 25, and I'll type that relative frequency here. And I'll continue to do that. So for the next one, I have 10 counts, or 10 was the frequency. I divide it by the total, and I get 0.4. And I just continue doing that. And of course, 0 divided by 25 is going to be 0. There are some other ways that you can do this problem in the calculator. I have a separate video about that if you'll look back at the playlist. And there's also StatCrunch. So let's look at StatCrunch. So we'll open our data in StatCrunch. We're going to select Data and scroll down to find Bin. We'll select the column. There's only one column here. And we want to use fixed bin widths. This is the information that we were given in our problem. And I got a lot going on here on the screen, but it has this lower class limit of 30,000. That's where we want our bins to start. And we want our bin width to be 6,000. Usually everything else is set up already here, but just to be clear, we want to make sure we include the left endpoint of the bin. And then we'll click Compute. Next, we're going to go to Stat and highlight Tables, and then Frequency. We'll then click Bin of that first column. In this case, it was just labeled R1. And under Type, we wanted both, actually. We want frequency and relative frequency, and I see that both of these have been selected here, but just in case, you could always multiple select by using Shift-click. And then Compute. And here are our frequencies and relative frequencies. Notice that the only difference is that interval that did not contain any values, it had a frequency of 0, would not be listed here in this chart, so I would still have to manually enter that information. Also notice that the class width is not the same here as what we have inside of StatCrunch, but the reason why is I don't want to overlap these two bins. If I say that this first bin is going from 30,000 to 36,000, and I'm not very clear, then what do I do with a data value of 36,000? Does it come here or does it come here? Now, StatCrunch isn't doing anything wrong necessarily. It said that we wanted to include the left endpoint. So if I see 36,000 show up in my raw data, I'm going to include it in this particular class width or class interval. I don't include the right endpoint. So notice that's on the right of that interval. I would not include it here. I'm going to include it when it's on the left. To make that more clear, inside my math lab, we just back up 1 unit, as you see here in that class interval